In this lesson, we're going to take a look at experimental and theoretical probability. Let's take a look at the words themselves. The first word, experimental, has the word experiment in it. An experimental probability means we try it out. We roll a die or we spin a spinner and we see how many times it lands on a certain number or a certain color or whatever it is we're looking for. Theoretical probability has the word theory in it. And a theory is just that. It's what we think should happen. And we know in real life it doesn't always happen that way. So this is the what we think should happen, and this is the real life experiment of what does happen. So let's take a look at an example. We know from doing various games and talking about probability that when we're rolling a die or a number cube, we should, of every 6 rolls, get a 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And in theory, that's a beautiful idea. We would get that. But in this experiment, Martina rolled her number cube a total of 25 times. And out of those 25 times, she got these results. She got a 1 5 times out of 25, a 2 3 times out of 25, and so on. So from her results, compute the experimental probability that she rolled an odd number. So how many of these are odd? Well, a 1 is odd, 3 is odd, and 5 is odd. So out of the 25 times she rolled, she got a 1, 3, or a 5 14 times. 5 plus 5 is 10, plus 4 is 14. 14 out of 25 times she rolled an odd number. Now it says round your answers to the nearest thousandth, so that tells me I have to use some decimals instead of my fractions. When I wrote it as a fraction, I just get my calculator out and divide 14 divided by 25. Oops. 14 divided by 25, and why I can't make that say 25. 14 divided by 25 equals 56 hundredths. Now, since I have to turn it into a to the nearest thousandths, Alex likes it if we play by the games, so instead of 56 hundredths, I'm going to make it 560 thousandths. And that's the answer for A. For B, assuming that the cube is fair, compute the theoretical probability of rolling an odd number. Well, odd numbers happen half the time. Even numbers happen the other half. So half of the time is 5/10ths of the time, or 5/100ths of the time. So our theoretical and this is our theoretical probability, and this was the actual probability, the experimental probability. They're pretty close. The more times that Martina rolls this, the greater she would get to the theoretical probability, because in theory, the more times we do an experiment, the closer we get to the theory. So experimental becomes closer to theoretical the more times we do it. So assuming that the cube is fair, the statement below that is true would be that with a small number of rolls, it is not surprising if the experimental probability is greater than the theoretical probability. We have a small number of rolls here. With a small number of rolls, it's surprising? No, it's not. With a small number of rolls, the experimental probability will always be greater? Not true. Smaller number of rolls, it's not surprising that it is greater than in theory. I hope this helps you with the lesson. Good luck.